Hey guys, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to my videos here, my product development series. So, I don't think we're going to be able to do the water jet. I mean, I'm going to talk about it and see if there's anything else that we have here to do. So, I'm talking with that supplier for the hosing about what's it called? The pump and the cutting head. So if we look here, here is basically the inside of the pump. This is the exit, and you can see we do indeed have a countersink here. I can't, but here's the deal. I can't exactly tell if it's 60 degrees. So probably what I'm gonna have to do is I'm gonna have to get probably my 1/4 inch countersink that's 60 degrees and shove it in there and perfectly on center, and basically re-drill that to 60 degrees. But then if I re-drill it, then the shavings will get stuck in there. So, and then they'll get stuck in the pump and we'll jam the pump up, because this is a pretty small hole. Basically, the chips are going to have to come back out through this hole. And that may or may not happen. So what will probably have to happen is I have to unscrew this thing, and I don't know how I'm going to seal it back up. So I'm going to be talking to this supplier, Julier. I was supposed to talk to him last night, wasn't able to. One of my friends in town was leaving. He's moving to Colorado. And so I was hanging out with him yesterday. That's why I'm shooting this video this morning, and I'll also shoot a video later tonight. So we need to figure out if this is a 60-degree taper in order to seal. And we have this guy. This guy's the inside of the cutting head. This is without the orifice. And if you'll notice, this is straight cut, and then the orifice falls in there. Let's see, where's the orifice picture? Did I not send an orifice picture? Oh, there we go. So there's the orifice in there, and there's the ruby, and then the ruby's got a small hole in there. So this is actually the only thing. So here's the thread, and then here's the little shelf here. There's a little counter bore in there, but this is flat. And then the orifice itself has a 60-degree, like negative on it, basically. So, it's got a 60-degree negative on it. So basically what happens is, what we could do is we could have them do a 60-degree negative on it, so that it basically has this, comes down here and seals around the orifice itself. But remember, the hosing on that is only 1/4 inch. So I'm going to have to go measure this guy here, and maybe even talk to AccuStream about what angle this orifice head is and how it was originally designed. So maybe I could do that on the way to work. I call Tim my way into work. I didn't do anything with it yesterday as far as going to work, but I would like to talk to Tim, and then first probably call AccuStream, talk to them, and not Julier till later tonight, because they're in China, so they're not up till later tonight. So go talk to them about where they normally seal around, but we'll probably seal around the orifice. So I'm gonna go down on this M15. No, this is the 7/8. So 7/8, 18. Go down and press onto this orifice, and then basically seal around this orifice here. And then so press down on this taper on the orifice, which is all a really nice machine taper. Otherwise, we have to seal around here, but if we seal around here, I think there is a hole down here somewhere for some air gap, something. So that might not work either. So basically, shove that hose down in there and adapt around this. So we'll see, because again, if this is, you can see that this area right here is flat. So if that's bigger than quarter of an inch, we're in trouble. But if out here is quarter an inch, then we're okay. So we will look into that further, and then we'll give you guys a update on when we have enough information to do a whole video. So those are the two things that we're looking into is, sure, in drawing, okay, 60 degree, it seals, but in actuality, do we have that? So do we have 60 degrees here? And obviously we don't here. This is actually 60 degrees down. Instead of this way, it's actually this way. So it's actually the opposite direction compared to a regular counterbore, right? Not a counterbore, a regular chamfer, I guess. It's basically a chamfered edge. In words at 60 degrees or whatever degrees. This might be 45, so I'll have to talk to Julier, and then they will tell me if this is 60 degrees, this will work with Tim's setup, no problem. But this one will definitely need some modification. Alright, so let's go ahead and close these. So again, this is basically the orifice falls in there. The orifice has got a little shoulder, it's straight, and then the orifice goes in there. You can see very, very clean machining on that. Alright, so another update. Working on sending out the shredder files. I have all the tolerances and stuff set up for this supplier, and I'm going to talk to the supplier further. That's also another person I need to talk to. So I need to talk to these guys as well. And then basically what I'm going to do is I'm going to order probably a minimum of 9 shredders from these guys as an initial order, and then I'm going to order a 4x8 sheet, which makes 8. So then you're like, okay, well, where's the 9th coming from? I'm going to order one standalone 2x2 sheet that they could load onto the machine and cut, and then send me the parts. So basically what that's going to do is that's instead of having the 4x8, cutting a piece out of so loading the 4x8 on, cutting the piece out of 4x8, taking the 4x8 off, and then storing it and waiting for me to say, hey, this looks good. So instead of them storing for like a week for me to test that everything's good before I give them the go-ahead, I could just send them the 2x2. They cut one, they send one to me. They basically got rid of all of their sheet. They throw that sheet away because basically it's gone. They send it to me. I put it together within that next week. I give them go ahead on the 8-piece run, and I have the 4x8 shipped to them. So that is the idea. So that way it's the easiest for the supplier to get that done. So that's my thoughts, and I'll definitely talk to them more about it as well. It's not a person I need to call. So basically what we're going to do in this video is we're going to go back and look at our DIY, the Green Machine mill or the DIY mill router. We'll see what else we can do here, because basically these two are our two primary projects. The router is separate. So once this is done and we're doing this and we see it compared to the mill on what exactly we would need in addition to do mill it so that it's done assembled. Once we figure that out, then we could go to the next step, and then the next machine after this, or the water jet would be, it's probably still build the mill, and then it would be the CNC laser. So that would be the next thing that we would work on, the CNC high wattage CO2 laser. Alright, so here we are. And now, so I can't remember if I double checked the distance here. Because again, we have 48 inches. Okay, so let's get that down. That first one down. Let's write it here. Oh no. Do I not have my pen around here anymore? We could put it in this guy. I need a little hanger for my headphones. I have to print one of those. It's pretty heavy, so I'll have to probably use 2 of these little command strips. Okay, so let's move that to the other screen here. So 28.552. Actually, no, I shouldn't be doing that. I should be doing this one. I'm just going to say 28.5. See, that's good. It's pretty close. And plus 19. That's 47.5 inches. Plus a little bit. Okay. So I think that would work. Okay, so one of the things that we could do is get the high wind rails, the right high wind rails. But I'll probably do that off screen. I mean, you see me changing in and out many times. So, I mean, the next step really is how and where am I going to mount the motors. So I can mount them here. Then they're going to protrude out into the room. I can mount them. I can mount them here as well, but basically it'll hit the beam when they're all the way when it's all the way over here when this is milling this corner. Okay, and then also theoretically, because it's 48, that's 24 inches of travel, I think. So that's pretty good. And then this is 20 something. Or, I mean, basically you could do this where it's protruding off the table, but now obviously it's in the room. But it's not that bad in the room because it's going to be, it's super tall. So it's okay if it goes in the room. Yeah, so that's a good question. Where to put the motors? I mean, you could have them hanging underneath here. And so even if it comes in, it's going to go underneath. We could put them inside the table somehow, because this is 2 point something inches, right? It's 2.5 inches. So let's see, what's the biggest motor that we could put inside there? What's that company called? So online. Stepper, OMC Stepper Online. Okay. So, what? Why is it in Dutch? Okay, so, here's the size. So we're looking for something under 2.5 inches. That's 63 millimeters. So NEMA 23 is 57 by 57. 57. It's only a 1/4 inch thickness at the top, which is not a lot. Oh, and I got my calipers here in the room here fixed, so that's good. That could work. And then, but that will just barely clear. What's the next size lower? Oh, did I look up 57? Yeah, it's 57. Wow, next size is obviously NEMA 17s, which is 42. Wow, so now it's 0.9 inches smaller. I like to run NEMA 23s. So I wonder if I could get away. Ooh, and then we have to have the wires. We'll have to route a little hole for the wires to get out. A little channel along the side for the wires to get out, but that's fine. I'm wondering if I could mill this down or something. And then also how to mount this. So basically I would need a little piece here. So let's see how that would work. So let's open up the custom, this should be the X. There's my niece crying, probably fell or something. 28.5, 28.5. Okay, so let's say here. What is this? This is not a 1/4, this is like 3/8. Oh, that's 0.8, okay. And then basically let's do this. Let's find the middle here. And draw from the middle down. Mark this up. And then we have 57, it's 57 millimeters divided by 2. One second, let me text this guy back here. Okay, so let's go 57 millimeters divided by 2. Okay, and then square 57 millimeters. 57 millimeters by 57 millimeters. And so there is the top skin. So that's going to be a little thin. I mean, this is going to be butted up against it, so, and it's going to hit here. So it is going to help it stay nice and rigid. So I mean the motor is going to be there keeping that thing from bowing up there. So I mean that's not that big of an issue. And 1/4 inch thick steel across a 2-inch span is not that bad. But let's see anyways. So let's say actually let's close that. And what we actually want is we want here. And then let's project include. And so let's also give it a 1/4 of an inch here. To bolt onto. I mean, we could do even more. Pretty much what I plan on doing. Let's go to the extents of what this has. So let's find one. Let's say something like 57 by 57 by 57. Or 56. Obviously, we want 4 wires. 6 wires, 6 wires, 4 wires. Okay, now we're getting in the big boys. 8 wires, 4 wires, but a 6mm shaft. And we want the big shaft. For to resist 76. Okay. About 3 inches. That's a big motor. I don't think we need anything bigger than that. That's probably the biggest that we need. And then also remember that if we do that, then basically the other motor for this would go up here. Oh, yeah. For the Z. And then for this guy, this guy we don't have any room. This guy could go underneath because we're not too worried about the height, right? That's another thing that we could do here is that we could lift this up further so we don't have to drill so far in. So that's another option, is to lift this guy up, and then we could have it like here, and then the motor will still clear. But basically this is going to have some legs underneath it, and then sit on top of this pan. And we don't want to make this bigger to fit the motor in, because then we're going to lose some travel here. So stick the stepper motor underneath here and then have it come up, and then the pan, the chip pan, is going to be down here. Okay, so now let's make it this but 3 inches long, let's say. I think that that's fine, 3 inches. So now we're going to do that, and then it's going to be 57 deep, I believe. Yes, 57 deep. Oops. Negative 57mm. And obviously this needs to be rounded, filleted. But the fillet comes inside. Is there a way to push it in? Or, I mean, we could do it in the drawing. Let's say it's a 1/4 inch, or let's say it's a 3/8 mil. 1325 divided by 2. Oops. Fillet, this one, this one, this one, and 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 this one. What? Play 163. What? 163. There it goes. Why does it look like it moved over? Oh, it's not constrained this way. 57mm. There we go. Okay, so 57. So let's make this 60mm. And let's make this 3.1. And also So let's make this guy collinear. There we go. And then technically we should probably move let's go ahead and get rid of how this is held. And let's constrain this way, 0.25. And then let's do this. Actually, we could do a centrer. Let's do a constraint center. There we go. And what does that mean with respect to this? About 1/2 inch. Perfect. Okay, but we only have a 1/2 inch ceiling. So that's why I'm saying we put like a little plate. A little plate under here. A 1/4 inch plate that we mount this. Actually, we do have to put a plate down here to mount it anyways. So you can put a 1/4 inch plate, 1/4 inch plate. And then basically what happens is that this guy actually only goes in. But then the issue is that we're only probably going to get 2 bolts in here. Because then we have one that's not... We have something that you can't bolt in. But what we can do is you just put a bolt under there, under this to shim it forward. And you put the bolts here. And then you put a bolt through there, bolt and nut or whatever. So let's say that we did that, and then this guy was actually minus or plus 0.25. So now we should have a 1/4 inch floor, but obviously that would need to be CNC'd, and this is 28 inches long. It should fit on the bed of the Tormach. I mean, we can machine it where this is open. Just go in there and machine it, or we can machine it on the Tormach. The Tormach will make it stronger. Basically, the next thing that we would need to do is drill these, and then put the plate on here. 1, 2, 3, 4, and put the plate here. And then the plate, basically you mount the motor on there, and the plate would be the same as this. It'd be a 1/4 inch plate, and it would keep this sturdy. So that's another thing that we could do. Mill, PCNC 1100, technical specs, table size, 34 inches. So 34 inches, that this guy will fit on there. Alright, so that's basically the X motor, and then but that's on the negative side, basically. So let's go ahead and save this without having all the sketches on. Oh, and then obviously we need a sketch, edit sketch, and let's look at this NEMA model. Let's go ahead and open up this guy. And so we need the standard. Okay, so we need 38. Like that. Uh-oh. Get rid of this, get rid of that. Actually, we could have those, but just take that out. Make sure that's centered. It's okay, tickets. It's okay, tickets. And there we go. Let's see where it ends up. Perfect. It's on the side I was thinking it's going to be on. And then we'll model these this 3-inch motor. And same deal here. It'll clear with a 1/4 of an inch here. Not a problem, because then again, this is probably going to have a 1/4 of an inch. That's going to stand it out anyways. So it's going to go here, the next motor, the motor itself, and then obviously this motor is going to have a pulley that goes over here and attaches the ball screw, some sort of reduction, probably a 3-to-1 reduction, because we're not feeding that hard. So yeah, I'll show you guys that. I'm using it also in the Fill Factory. I need to get this one, and then again the motor for this guy, the Y, is going to go underneath because there's going to be feet that go here that attach it to that stand it up above the chip tray, and that that bolt it up to the chip tray. So there might be a hole right through the foot and a thread in the foot, and you just bolt it down to the foot. So next thing that we're going to do is we're going to bolt the motors. I'm going to get the right size linear rails, get that working. And then also, like I said, I had a phone call from these guys from Highwind, because I basically downloaded those files, and then he told me a little bit about Highwind. So we'll see if we get some actual original Highwinds instead of, you know, the China is probably hit and miss, but we'll see there. So yeah, this has been Steven from Legit Tech Tutorials and the Green Engineers. I'd like to thank you guys for watching. If you liked the video, please subscribe for more videos like it, and I'll see you guys next video. Take it easy. Peace.